Hello there. In this video we're going to talk about how to classify the steepness of a line or line segment via quantitative measurement known as the slope of that line or line segment. So you can visualize, say, points in the xy plane. So consider the x and y axis. So let's consider a particular starting point, say A, and let's project line segments or rays from this point A. So we can consider that line, or that line. Then we pretty much say that the yellow line is more steep than the green line, and the green line is more steep than the red line. Because if we draw pretty much a right triangle with respect to all of them, then the altitude of that right triangle is going to be a little bit more shallower than the altitude of the green one, and of course the most steepest one would of course be the yellow one. So in this video we'll pretty much decide how to assign a measurement to this steepness in 2 dimensions, and then we'll discuss a couple properties associated with it. So as usual, we'll begin with the definition of what we're going to call the slope between 2 points. So let's assume we have 2 points, P1 and P2, with their coordinates x1, y1, and coordinates x2, y2 respectively. So the slope, which we're going to be abbreviating by m, is defined to be the following relationship. So the slope between P1 and P2 is defined to be equal to y2 minus y1 over x2 minus x1, and you may see some people abbreviate this as just delta y divided by delta x, or the change in the y direction divided by the change in the x direction. So from here, what kind of properties do we have? So so the slope between P1 and P2 is equal to the slope between P2 and P1. That is, you can interchange these components and get the same exact answer. Some people believe this is false. So let's prove this right quick. So prove. So the slope between P1 and P2, by definition, is going to be y2 minus y1 over x2 minus x1. So what we can do is we can multiply top and bottom of this expression by -1. So this is going to give us negative y2 plus y1 divided by negative x2 plus x1. And then by the commutative property of addition, we can rearrange these expressions. So this is just going to be equal to y1 minus y2, all divided by x1 minus x2. And of course, this is the slope between point 2 and point 1. So it doesn't really matter the order for which you subtract them as long as the indices match up perfectly. Let's look at the definition of slope from a geometric perspective. So let's consider the xy plane. And it doesn't really matter where you put these points, but I'm going to put them in quadrant 1 just for comparison. So let's call this x1, x2. So that's the vertical component. So let's call that y1 actually. Let's consider another point up here. So this is going to be x2 for point 2, and this is going to be y2 for point 2. So this is point 1, and this is point 2. Let's connect these points with a line segment. And let's construct a right triangle out of these 2 points. So this distance right here is of course x2 minus x1. And this distance right here is, of course, y2 minus y1. So this is what we call the change in y, and this is what we usually refer to as the change in x. So the slope, or the steepness of the line, is defined to be equal to the ratio of the change in y divided by the change in x, and some people usually call this the rise divided by the run. But that's not usually a mathematical expression, it's just there to sort of help you remember, does the y go on top or should the y go on bottom? Okay, cool. So let's do a couple examples to sort of get some basic properties or observations about the slope. So example 1. So let's consider 2 points in space. So let's consider the point 1, 3 and the point 5, 7. And let's consider the line that passes through them. Let's call that line L. So what is the slope of this line? So the slope of this line, so m sub L, is going to be equal to the change in y divided by the change in x. So I'm going to call this point, let's say x1, y1, and this point x2, y2. So as we know, this is going to be y2 minus y1 over x2 minus x1. Or you can do y1 minus y2 over x1 minus x2. We've already proven that they should give you the same answer. So y2 is going to be 7 minus y1 is going to be 3. Divided by x2 is going to be 5 minus x1, which is going to be 1. So 7 minus 3 is going to be 4. 5 minus 1 is going to be 4. So we see that this is going to be equal to positive 1. So let's do another example. So example 2. Let's consider the point, again, 1, 3. And let's choose another point, say 5, 11. 5, 11. So 5, 7 used to be down here. So here's our old line. So now I'm considering this line here. I'm going to call this line L2. So let's find the slope of line L2. So the slope of line L2 is going to be equal to, so I'm going to call this x1, y1, and this x2, y2. So y2 is going to be 11 minus 3 divided by 5 minus 1. So 11 minus 3 is going to be equal to 8. 5 minus 1 is going to be equal to 4. And 8 divided by 4 divides evenly into positive 2. So notice we have, and we're choosing the same exact base point, 1, 3. So what can you tell me about the difference between these two numbers? And the comparison geometrically with the blue and yellow lines. So definitely the yellow line is more steeper going from left to right. And notice that we have a larger number here as well. So let's look at another example and see if we can come up with an explanation of how this slope is going to compare. So I'm going to pick a couple points here. I'm going to pick the same point, 1, 3. Now I'm going to choose the point 7, negative 4. So let's draw this line here. Let's call this line L3. So what is the slope of this line? So the slope of L3, let's call this x1, x2, or x1, y1, and x2, y2. So y2 is going to be negative 4, minus y1 is going to be 3, x2 is going to be 7, minus x1 is going to be 1. So negative 4 minus 3 is going to be negative 7, divided by 7 minus 1 is going to be 6. So of course this is going to be equal to negative 7/6. So it's a negative number, and this line is going down. So we can pretty much see that, maybe if the slope is negative, then maybe this line is going down from left to right. So let's consider another example. So let's consider the point 3, 4 and the point 7, 4. Let's consider this line here. Let's call this line L4. Now, what observation can you make about this line? So this is a horizontal line. It's a flat line. Well, all lines are flat in some sense, but it's pretty much like standing on ground type of flat line. Also notice as an observation that the y-coordinates are the same. So they're the same. So let's calculate the slope. So let's call this x1, y1, and x2, y2. So the slope of line 4 is going to be equal to 4 minus 4 all over 7 minus 3. So 4 minus 4 is going to be 0. 7 minus 3 is going to be 4. And that quotient is going to come out to 0. So we can see, maybe, for a horizontal line, that the slope is going to be equal to 0. Let's consider another combination of points. let's consider, let's see here. Let's do the point 3, 5, and let's do the point 3, 7. So this is going to be the line of interest. I'm going to call this L5. So what is going to be the slope of L5? So the slope of L5 is going to be equal to, let's call this x1, y1, and x2, y2. Doesn't really matter the order, right? So this is going to be y2 minus y1 all over x2 minus x1. So 7 minus 5 is going to be 2 divided by 0. And you cannot divide by 0, so this is undefined. Also notice that this is a vertical line. And also notice that the x-coordinates do not change. So maybe you can come up with a conclusion about that. So with all these things in mind, now let us try and come up with a summary list that tells us everything that we should know about slope. So I'm going to draw a couple graphs, and I want you to try and tell me something about the slope of these lines. So let's consider a line like this. Let's consider a line like this. Let's consider this line. And also let's consider this line. So what can you tell me about the slope of each of these 4 lines? So if this is the x-axis and this is the y-axis, and the line goes up from left to right, then we can at least say that the slope is going to be positive because it goes up from left to right. Similarly, if it goes down from left to right, then we can say that the slope is going to be negative. If the line is a horizontal line, then the slope is going to be equal to 0. And if it's a vertical line, then the slope should be undefined. Some people may say infinity, but of course infinity is not a number, so try not to get too comfortable with saying those types of things, at least too early. So the slope doesn't exist is another way of saying it. So let's see if we can come up with a couple other summaries. So let's consider a couple scenarios here. So let's consider this line here and this line here. So let's call this slope 1. Let's call this slope 2. Let's consider 2 more lines. Let's consider this slope 3. Let's consider another slope 4. So what can you tell me about the difference between these 2 slopes? Well, clearly both M1 and M2 are positive because they're both going up from left to right, but which one of these slopes are bigger? So if you said that M2 is larger than M1, then you are correct. And you can also say that both of these slopes are positive based on this picture. Similarly, M3 and M4 are all going to be negative slopes since the lines are going downwards from left to right. So which line has the least or greatest negative value in these things? So you should know that M4 is going to be less than M3, and both of these numbers should be less than 0 since the lines are going downwards. So these are some just basics in regards to lines. And there's 2 special cases, of course, that you need to remember: that the slope of 2 positive lines, or the slope of horizontal lines, I mean. So the slope of horizontal lines are 0. Another property that you should come away with: the slope of vertical lines do not exist. The slope between point 1 and point 2 is equal to the slope between point 2 and point 1. And also another property that you may also know by observation: for any points P1 not equal to P2, the slope between point 1 and point 2 is a unique number. So that means no matter what 2 points you choose, the slope between those 2 points is always going to be unique. Therefore, if you think about relations and functions, M is going to be a function whose domain is the set of all pairs of points, and whose range is the set of real numbers. And that's just some basic applications associated to lines and their slopes.